Hello and servus from Bavaria. My name is Stefan Keri. I'm the product manager for textile applications at Marlow here in Germany, in Bavaria. We all know the situation that our pants that we love most have gone through the laundry, and when they come out, they only fit our pet toy. And as much as we love our baby bear, we want to have them ourselves. So today we want to go through the subject of shrinking. We can control the shrinking up front, we can anticipate whatever is happening with the fabric, and we can control the shrinkage up front. How we do that? I'm going to show you. Let's jump right in. Welcome, ladies and gentlemen. Today's topic is about residual shrinkage and how to avoid it. And I want to start to introduce a little bit how the residual shrinkage is taking place and why it is giving so many headaches to the production manager. So residual shrinkage is known by all of us. If we buy a t-shirt and after the first washing it doesn't look like that anymore, but it looks like you have bought it for your kids. And this is mainly happening with the knitted goods. It can also happen with some woven goods, but it's mainly a problem which is coming from the production process of those knits. And also, due to this production process, this variation can happen not only from piece to piece, but also within one piece. Why? I'm going to explain you. You have different knitting machines, dozens, sometimes hundreds, and those different knitting machines have different setups, different features, and they already produce some unequal fabric and unequal lots. It's getting worse when it comes to the wet finishing, when it's also fully soaked with water and dye stuff and chemicals. It is also treated with different dyeing machines, different jets and different operators. Some of them are treating the fabric with a lot of gentle and a lot of soft movements, but other operators are treating the fabric with a lot of physical force and therefore apply a lot of tension to the fabric. So normally, to see whether or not this tension is being too much and the density has been affected too much, we do the tests with a washing machine and a tumbler to see whether or not this fabric is still meeting the requirements. But of course, during the production process, we cannot do that. So during the production, it is breaking down to two different measurement areas, and this is the area weight and the linear density. It also goes without saying that taking a sample, putting it to the lab, drying it, conditioning it is also taking too much time. So the only way to get an online measurement of the residual tension is to measure the linear density continuously. To do so, we have our TK scanner. This is a scanner that we also use for the weft straightening, and therefore we have built that 1,000 times already. It's a very reliable instrument. It's a very reliable tool which is working with a light-dark modulation, and unlike with the weft straightening, this sensor is not swiveling 8 times a second. It's standing still and it's adjusting itself according to the highest signal. So it's always looking for the best light-dark modulation, and it's self-adjusting, so you don't need to care about it anymore. And as you can see down here with the frequency, it is giving you a very clear indication about the different picks or the different courses all the time. So where do we put that different sensors? Perhaps the most important is at the inlet, where we have an intelligent forward control measurement, which is directly giving an input to the overfeed of the stander. But then, of course, we also have one at the exit, because this is where we want to know what has happened. Here you can see clearly the different frequency of the fabric before, and this is after. You can see quite clearly that the difference is very, very even and very controlled. Let's give you a small example. If we are coming with 20 picks or 20 cores per centimeter, and we will have an overfeed of 25%, we'll end up with 25 picks per centimeter. But as we have learned before, it is not always coming with 20 picks per centimeters. Sometimes within one piece, it is also having 18 picks per centimeter. And if we are carrying on with an overfeed of 25%, we would end up with 22.5 picks per centimeter. This is not what we wanted. In order to achieve the 25 picks, we have to increase the overfeed to 27%, and then we will end up with a target value of 25. And this is also a value that will be shown at the exit. This value you can share with your customer. This value you can share inside your company. You can make it transparent by our Industry 4.0 measurements, so that can be transferred to every person that is required to do so. So this is actually how it would look like for the normal scanner. If we are having now the need for a weight indication, and unlike the woven fabrics, knitted goods are always sold by weight, so it is quite important. Then we use a camera-based scanner at the exit, and this camera-based scanner is giving us an indication not only about the courses but also about the wales, and therefore calculates the weight every time automatically. And this is doing a very good assistance for the sales process. It is giving you an insurance that whatever you have achieved during the production process is meeting the requirements that has been discussed with your customers. So again, a quick rundown. The web density entry, the density at the exit is quite important to control the overfeed accordingly, and this overfeed control makes sure that you have always the right density and therefore also the right residual shrinkage, and so the values are always within an acceptable target, and make sure that the t-shirts that you produce will not be only with your kids in the future but stay as they are. I hope that we could actually contribute a little bit of solution to your problems, and that we could actually also help to make your production a little bit better. Thank you so much. Thank you very much for watching. Now you should know how to avoid that your baby bear has more underpants that fit him than you. So if you liked the videos, I would be glad to get a thumbs up from your side. If you have any other suggestions or comments, also just leave them on the comment section. If you haven't subscribed to our YouTube channel yet, that's the time and place to do so. Then you won't miss out on any other YouTube videos that we produce according to the issues of the textile production and finishing. Thank you very much for watching. My name is Stefan Keri. Have a nice day.